Hello, geometry students. This lesson is on section 3.1 on the composition of transformations, and we're going to start your notes on graph paper. So you will need your book eventually, but right now you need a piece of graph paper. What I'd like you to do is pause your video and work on steps 1 through 4 right now on your graph paper, and then press play when you're all done. Okay, let's go ahead and check and see how you did on this exercise. So if we plot the points 2, 5, point A, point B is at 4, 5, and point C is at 3, 8. So if we connect those points, we get a triangle. And now first, for step 2, we're going to reflect these points across the line y equals x. And so the line y equals x looks like this. And so point B prime would end up here when we reflect. Point A prime is going to be here. And point C prime, let's see, that's 1, 2.5 steps away. And so if we go half, 1, 2 steps away, there is point C prime. And so reflecting across the line y equals x gives us those coordinates. And now step 3, now we're going to reflect those points across the x-axis. So point A double prime would be here, point B double prime would be here, and point C double prime would be here, giving us that image. And so now the question is, how can we, for part 4, is there a single transformation that would have gotten us from here to here in one step? And so it might help if we look at the coordinates. A double prime ended up at 5, -2. B double prime ended up at 5, -4, and C double prime ended up at 8, -3. So you might recognize that transformation. It looks like the x's and the y's switched places, and what was the x became negative when we put it in the y position. We've seen that before. That's actually a rotation 90 degrees. So if you compare point A to A double prime, we see that that's just a 90-degree rotation. If we compare point B to B double prime, we see that is a 90-degree rotation. And if we compare point C to C double prime, we see that that is also a 90-degree rotation. And so reflecting across two lines is always equivalent to a rotation. It's not always a 90-degree rotation. In this case it is, but if you do 2 reflections in a row across 2 different lines, that's always the same as a rotation about the point where the reflection lines intersect. Okay, and so when we combine 2 or more transformations together, we call that a composition of transformations. And so in this case, the composition of 2 reflections was equivalent to 1 single rotation. Okay, so now we're going to go to page 118 in your text. And we're going to work on example 2b. And so this is showing two transformations, one that multiplies the x by 3 and the other that multiplies the x by 1/2 and then the y by negative 1/2. And so we have two transformations going on there together. And so if I start with the point A, which is at 0, -2, then the first transformation is going to send it to 3 times 0, which is still 0, and y, so that point didn't move. The point B is at -2, -4. When you multiply the x coordinate by 3, that becomes -6, -4. And point C is at -4, -4. And that is going to end up at -12, -4. So that's just the first transformation. Now the second transformation says multiply the x coordinate by 1/2 and the y coordinate by -1/2. So then that's going to be still 0 and then +1. Multiply -6 by 1/2 and you get -3. Multiply -4 by -1/2 and you get +2. And -12 times 1/2 is -6. -4 times -1/2 is +2. And so we see our transformation ends up at point A is at, so A double prime would be at 0, 1. And then B double prime is at -3, 2. And C double prime is at -6, 2. And so our image is here now. And we see that that figure is not congruent to the original figure, so that means this must not be a rigid transformation. Change the shape of the triangle. So this is not a rigid transformation. Okay. And then moving on to page 119. This time we have 3 transformations for problem 11. We have 3 transformations in a row. And so go ahead and pause your video, write down the coordinates for A, B, and C, and then apply the 3 transformations and see where your image ends up. So point A, the first transformation says subtract 1 from the x and subtract 1 from the y, so that's going to give us 1, 1. And then the next transformation says multiply the x coordinate by 3, so now it's 3, 1. And then the next transformation says change the sign of both the x and the y, so that's -3, -1. Point B, if we subtract 1 from both coordinates, that's 1, 4. Multiply the x coordinate by 3, makes it 3, 4. And change the sign of both, -3, -4. And then point C, if you subtract 1 from both coordinates, that's 2, 1. Multiply the x coordinate by 3, makes it 6, 1. And change the sign of both, makes it -6, -1. And so point A, -3, -1 would be here. So that's A triple prime. B is at -3, -4. So that's B triple prime. And point C is at -6, -1. That would be C triple prime. So our new figure looks like this. The triangle has changed its shape, so this is not a rigid transformation. Now let's go on to the exercises section, which starts on page 122. We'll do problem 2 together. It says rotate the figure 90 degrees clockwise about the origin and then reflect over the x-axis. So if I rotate this point 90 degrees clockwise, point A ends up here. Point B is going to be here, actually here. We can do the algebraic transformation for that if it helps. So we could say x, y is going to move to y negative x, and so b is at negative 3, 3, and it would end up at 3, 3. So 3, 3 is actually there, okay? And then point C is at negative 2, 4, and it would end up at 4, 2. So that's our rotation, 90 degrees. Now we're going to reflect over the x-axis. So if I reflect over the x-axis, this point's going to go straight across to there. This point's going to go straight across to there. And this point's going to go straight across to there. So here's our final image. And we see that that is a rigid transformation. The figure is exactly the same. All we did is rotate it, which didn't change the shape, and then reflected it, which also doesn't change the shape. Now I'd like you to pause your video and try problem number 3 and press play when you're done. Okay, so first they ask us to translate by the vector 4, 4, so that means every point is going to move right 4 and up 4. So point A would end up there, and point B, right 4, up 4 is here, and point C, right 4, up 4. Okay, so after our first transformation, it's there. And now the second part is to rotate 90 degrees counterclockwise about point A. And so this one, it might be helpful if you use your compass and protractor, but you can do it without, just because the 90-degree rotation is going to keep it on lines with a slope of 1 and slope of negative 1. And so when we rotate 90 degrees clockwise, this is 1, 2, 3, 4 diagonals away. So 1, 2, 3, 4 diagonals away. So point A, double prime would end up there. And then we can do the same thing with point B. And so if we go 90 degrees, so that line has a slope of 1, 2, 3, 4, 5, 6, and over 2. So if I go this way, 1, 2, 3, 4, 5, 6, and up 2, it ends up here. B double prime. So A double prime was here. B double prime is there. C double prime, to get from A to C, is up 1, 2, 3, 4, 5, 6, 7, and over 3. So if I go over 7, 1, 2, 3, 4, 5, 6, 7, and up 3, it puts C right there. So we'll have to relabel these. So this is C double prime, and this was B double prime. And so notice that we still have a triangle that's congruent to the first two that we got. And now we're ready for the last part, which is to reflect over the y-axis. And so point B, which is at negative 7, 4 is going to end up over here at positive 7, 4. And point C is at negative 8, 4 is going to be at positive 8, 4. And point A is at negative 5, 6 is going to end up at positive 5, 6. And so there's our image. We did a translation, which didn't change the shape. We did a rotation, which didn't change the shape. And then we did a reflection, which didn't change the shape. And so our final image is going to be here. This is B triple prime. This is A triple prime, and this is C triple prime. And that's it for today's lesson. Stop by office hours if you need help on any of this material. Have a great day.